Hello students, welcome back to the YouTube channel. This is lecture number 7 of current electricity. I hope you have seen the previous 6 videos on this chapter. So in this video we will discuss about the various factors that affects the resistance. So our topic is factors affecting resistance. So there are basically 4 factors which affect the resistance. Now I hope you know what is resistance. Resistance is the obstructions that is offered to the flow of current, means the flow of electrons. So the first factor that affects resistance is the material. Now there are different materials that we have: silver, copper, aluminium. They have their different conductivity. They conduct the current in a different way. So what is the reason for that? We'll discuss that a little while. So the first factor is material. Second factor is length. Length also affects the resistance. And how it resistance we will discuss after that. The third factor is the area of cross section. Now what is area of cross section? Let me give you a little idea about what is the area of cross section is. If you consider this as the wire, this part, this is the area of cross section. Okay, so you can say area of cross section indirectly tells you whether the wire is thicker or thinner. Okay, so you can write over here thick or thin. And the fourth factor which affects the resistance is the temperature. So these are the 4 factors which affects resistance. Now we have to discuss about these factors one by one, and we will also get some relation. Based on the relation we have some numericals. Probably we will discuss those numericals in the next video. So let's discuss these 4 factors which affects the resistance. Now if we talk about material, say substances like aluminium, silver, copper, if you consider these 3, they have more number of free electrons. They have more number of free electrons. And obviously, if they have more number of free electrons, their conductance will be more. They will conduct the electricity more because more number of free electrons. Electrons are the one which are the cause of electricity or current. So if they have more number of free electrons, they will be more the value of current. So what happens if there are more number of free electrons? Conductance becomes more, and obviously if conductance becomes more, resistance will become less. So resistance will become less. As we know, conductance and resistance are inversely proportional to each other. We have discussed that in the previous video, that conductance is equal to 1 by resistance. So if conductance becomes more, obviously the resistance will become less because they are inverse relation. So that is why these 3 are, not only these 3, there are many more, but if we take these 3, they are called as good conductors. So they are called as good conductors because they conductance is more, they conduct electricity more. Now if you take examples like tungsten, or even say plastic, or say wood, okay, they have less number of free electrons. So they have less number of free electrons. Now if they have less number of free electrons, the conductance will be less, and if their conductance becomes less, the resistance becomes more, so they will offer more resistance, so they won't let the current flow smoothly. So in that situation, these are called as insulators. So if we talk about the first factor, which is material, it totally depends on the amount of free electrons. If free electrons are more, then the conductance is more. If free electrons are less, then conductance is less. I hope you understood the first point which affects the first point which affects the factor of which affects the resistance. Now the second factor which affects resistance is its length, the length of the wire. Suppose if we consider two wires, okay, one wire like this and the second wire like this. You can say this is wire A, this is wire B. The wire A has more positive ions. Over here you can say more number of positive ions. And the wire B, since it is small, the number of positive ions are less. If they have more number of positive ions, then what happens? When this electron, suppose you consider an electron which is trying to pass through it, now that electron will suffer more collision, and over here it will suffer less collision. So as over here it suffers more collision, the resistance of this wire, say the longer wire, becomes more, and since it is a small wire, so the number of collisions suffered by the electrons will be less. So over here the resistance becomes less. So you can say more length, so more collision. More collision with what? More collision with the positive ions. And if there is more collision, there is more resistance. Similarly, if there is small length, okay, less length, then what you can say? Less collision. And if there is less collision, you can say less resistance. So over here you need to say, you just need to see one thing. If there is more length, more resistance. If there is less length, less resistance. Means what? If length becomes more, resistance becomes more. Length becomes less, resistance becomes less. So from here you can say length and resistance, they are directly proportional to each other. So their length and resistance are directly proportional to each other. So resistance is directly proportional to its length. Okay. So you can say R is proportional to L. So by this logic, you can make, one, okay, these numericals, I will do it later on. Just remember these things, that length, resistance is directly proportional to length. I hope you understood this point, and obviously you have to remember this, because after this video, you will, on the next video, I'll do some numericals, and over there, these all points will be used to understand or to do the numericals. So I hope you understood this point. Now let's see the third point. Now the third point is on the thickness of the wire, which is the area of cross section. Now let me make you understand this thing. Consider there are two wires, one wire like this way and another wire like this. So there are two wires which I have drawn. Now over here you have some positive ions, over here also you have positive ions. Now see the difference. If these are the positive ions and over there here you have the positive ions. So over here you can see the positive ions are separated from each other. So if any electron comes from this side, it can pass through these spaces. Means what? If the wire is thicker, the electrons will suffer less collision because it has some spaces in between. And if the wire is thinner, then the electron which is coming from this side, it will suffer more collision. You can say in a simple logic now, suppose you are going in a highway. Now obviously if you have seen a highway, it is a little broad, the roads are broad. So in a highway the chances of traffic jam is very much minimum. You can see that in highway you can go at a very high speed, because if the road is broader or wider, then the collision or the traffic jam, you can say the traffic jam is minimum. On the other hand, if the road is narrow, okay, if the road is narrow and from the one side say a big truck or a lorry is coming, and from this side also a lorry is coming, then you know what happens. There is a whole traffic jam in that situation in the next 5 minutes, because since the roads are very narrow, so big heavy vehicles, when they cross over each other, they don't get enough space to move. So as a result, there is a lot of traffic jam which happens not in normal day. So the same thing happens. It is a narrow road. If it's a narrow road, there is a lot of traffic jam. Means what? Now the positive ions are closer to each other. So if an electron is passing through it, it will suffer more collision. Over here the electron can pass easily through the spaces, and over here it will suffer less collision. So over here you can say what? Area of cross section. Area of cross section is more. If area of cross section becomes more, what happens? Number of collision becomes less. And if you know, if number of collision becomes less, the resistance will obviously become less. On the other hand, over here you can say area of cross section is less. You can see area of cross section is less. So what happens? Number of collisions will be more, and if number of collision becomes more, the resistance also becomes more. So now you have to see very importantly these two pins: more, less. Over here less, more. So means what? If area is more, resistance becomes less, and if area is less, resistance becomes more. So how area and resistance, how they are related to each other? Think, it is not directly related, but now it is inversely related. So you can say resistance is proportional to 1 by area of cross section. So resistance is inversely proportional to 1 by area of cross section. And what is the area of cross section? Which I already told you. This is the area of cross section. Okay. Now look at it very more carefully, how this area looks like. Doesn't it look like a circle? If it looks like as it looks like a circle, what is the area of a circle is equal to? It is pi r square, where r is the radius. R means what? From here to here. This is called as the radius, r. So radius is proportional to 1 by area of cross section, which you can also say radius is proportional to 1 by pi r square. Remember these two relation, okay, especially this relation. Remember this relation, because we will use this relation to solve numericals after this. There are a lot of numericals which happens to come from this part only. by comparing the length and area. So I will do the numericals after this video, but try to understand the concept of it, how resistance affects on the area of cross section. So if it is a thicker wire, less resistance. Obviously, you must have seen when you are traveling by train and you have seen the high tension wires which goes in the field now. You must have seen the high tension wires which is going in the field. Those wires, if you look it closely now, they are very thick wires. And if the wire is very thick, if the wire is very thick, then there is less resistance. So the current through the wires, current flows through those wires very smoothly. So the wires are made thick, so there is less resistance. Of course, what happens if the wires are made thinner, then the resistance becomes more, and if the resistance becomes more, there is a lot of heating effect in the wire, and this heating effect can cause any kind of destruction. It can cause fire or something or the other. So to avoid it, the high tension wires are made up of thick, are made really thick. Okay, so this is the reason why they are made thick. We discuss that also in the later part. So I hope you understood this factor, how resistance depends upon the area of cross section. Now, resistance, the fourth factor or the last factor, resistance depends on the temperature of the wire. Now, how it depends, we will understand that. Normally, what happens is when you heat any body, suppose there is a body, and these are the molecules present inside the body. These molecules are, even at room temperature also, they are in the random motion. Okay, these molecules are moving randomly over each other. And when they are moving randomly in any direction, obviously there will be some kind of a collision. But what happens when the temperature is increased? Suppose you are, suppose you put a burning candle below it. Now these electrons or these molecules, their random motion increases. So random motion increases as the temperature increases. So when temperature increases, the random motion also increases. And this increase in the random motion will cause more number of collision. And we know if more number of collision, if there are more number of collision, the resistance also increases. So, what happens? If temperature increases, then the random motion of the molecules or say electrons, okay, random motion or say random motion of the particles also increases. If random motion of the particles increases, then what will happen? Then after that, what can happen? Number of collisions will increase, and if number of collisions increases, then subsequently the resistance will also increase. So you understood? So temperature increases, random motion of the particles also increases. If random motion of the particle increases, then number of collisions increases, and if number of collision increases, resistance also increases. So you can say this temperature and resistance are also directly proportional to each other. So you can see increases, resistance also increases. And on vice versa, you can say if temperature drops, okay, if temperature decreases, then this random motion also decreases, number of collision will also decrease, and resistance will also decrease. So we will discuss in superconductors, when we will study superconductors, this temperature decreases so much it is near about zero, absolute zero temperature, that the particles almost has no vibration, and if the particles has no vibration, the resistance becomes almost equal to zero. So we will discuss about that in superconductor. So anyways, you understood this part. When the temperature increases, resistance also increases. So this was about this lecture number 7. In the next video, we will discuss few numericals, and very important numericals come for your ICC exam related to this topic. So I hope you, if you have any doubts, you can write in the comment section, and the notes of this lecture you will get in the link down below. So take care, bye, good night.